Welcome to lesson number 5. We're going to be converting from general to standard form by what's called completing the square. Alright, so just a really brief review. So far we've looked at the general form and the standard form of a quadratic function, and those are given by y is equal to ax squared plus bx plus c, and y is equal to ax minus p squared plus q. Okay, so those are the two equations you've been seeing here. Now, what is completing the square? Well, first of all, we need to know what perfect squares are. Okay, so a perfect square, remember, is something like this: x plus 4 squared and x minus 5 squared. If we were to rewrite these numbers, we are going to have x plus 4 squared is going to be equal to x plus 4 times x plus 4. And so if we were to expand that, we would have x squared plus 8x plus 16. Now, a quick way to do this is if you think about this x squared, the first thing you're going to do is square that value because you have this this exponent. The next thing you do to get this 8x is you go x times 4, which would be 4x, times 2 would be 8x, and then you square that final term. The same rules apply for if there's a subtraction sign in between. You're going to start with x squared. Then you go 5 times x, which is 5x, times 2 is going to be 10x, but because there's a negative sign here, it's going to be negative 10x. And then we're going to square this last term, so negative 5 times negative 5 is going to be positive 25. And then down here, if we have x plus a squared, this is just going to be x squared plus a times x times 2 is just going to be 2ax. And then our last term squared is going to be a squared. Okay, so you can do these three by yourself, but this is how you do completing the square. And you should already know how to do that based on our last unit. Now factor the following expressions into perfect squares. So now we want to go from something like this, back into something like this. So what we do is we just work backwards. We know that our first term is going to be x, and we know that's going to be squared. But now to figure out what is going to go on the other side, all we need to really do is look at this term here. And so if we have a 9, we know that the square root of that is going to be 3. And since it's all positive, it's just going to be positive. All right, and so this one here, we have a subtraction sign here. And so I know what my square root of 4 is. It's 2. It's x and negative 2, which be x minus 2 squared. All right, so you can probably do these ones as well, but I'll just do this first one. It's going to be x plus 6, because I know the square root of 36 is 6, and that's going to be squared as well. Now, add an appropriate constant so that the following expressions can be written as perfect squares. Okay, so what we want to do is come up with this last term. Now, there is a process in order to do that. Remember that if we wanted to find out what the middle term was, we had to multiply the first term and the last term together and then multiply them by 2. So in order to find out what the last term is, we take the middle term, right? So the middle term is going to be the one that we're trying to multiply to get. But now we want to divide. So if we divide this by 2, we are going to get 1. Okay, so if we have 1 there, x plus 1 is x times 1 is 1x times 2 is 2x, which would have given us our middle term. But there's a better process to find or to complete the square. To complete the square of x squared plus bx, add half of the coefficient of x. Right, so this was our coefficient if we refer to our x values here. So add half of the coefficient of x and then square that. Okay, so half of the coefficient of 2 here is going to be 1. If we square 1, it's just going to be 1. So let's try that with this second one here. If we take half of 3 is 3 halves, and if we square this, go 3 halves times 3 halves, we're going to get 9 fourths. So that's what our coefficient is going to be. But what goes in here is going to be x, and that shouldn't be positive, should be minus 3/2 squared. Okay, over here, if we take half of our coefficient and square it, half of our coefficient in this case is going to be 9, because our coefficient is 18. And if we square 9, that's going to give us 81. 9 times 9 is 81. Okay, so then if we wanted to break this down, we're going to have x plus 9 squared. And with this last one, we want to take half of our coefficient of 1/4, so 1/8, and we are going to square that, which would give us 1/64. And so then that means that our factored form is going to be x minus 1/8 squared. So the process of adding a constant term to a quadratic expression to make it a perfect square is called completing the square. And remember, you take half of your coefficient of x, or b if we're talking about our general form of our equation, and then we take the square of it. Now let's use the following process to convert a function of the form x squared plus bx plus c into standard form. So this process that we're going to look at requires 3 steps. We take half of the numerical coefficient of the x term and we square it. Okay, so the numerical coefficient of the x term is that term in the middle, right here. All right, so we take half of that and we square it, and then we add and subtract the squared number in step 1, and this will keep the value of the function the same. And you'll see what this means in a second here. And then finally, form a perfect square and write it in factored form and simplify. Okay, so let's see how we would tackle that. If I express, I want to express x squared plus 10x plus 16 in completed square form, and then use a calculator to verify that both equations are represented by identical graphs. So my first equation is y is equal to x squared plus 10x plus 16. Okay, so the first thing is take half of the numerical coefficient of the x term and square it. So I want to take half of this, which would be 5, and I want to square that. Okay, so this is going to be x squared plus 10. If I'm going to take half of that, which is 5, and I'm going to square that, it's going to be 25 plus 25. Now add and subtract the squared number. So I added the square number, and now I need to subtract the square number. So plus 25 minus 25, and then I want to add 16. Okay, and so then this keeps the value of the function the same. So basically, we're not really adding anything to this. The next thing we need to do is form a perfect square and write it in factored form and simplify. Okay, so here is going to be our perfect square, like this. Y is going to be equal to x plus 5 squared, x plus 5 squared, and negative 25 plus 16. Negative 25 plus 16 is going to give us negative 9. Now let's see if these graphs are the same. Let's see if you can get a weird reflection on this calculator right now. Okay, so let's see. X squared plus 10x plus 16 graph. Okay, and actually let's zoom out of this here. Standard form. Okay, so there's our graph. Now let's graph our new function, which is going to be x plus 5 squared minus 9. Waiting. Okay, so I don't see any new lines on there, but so let's get rid of this first one, and it's the same. So our graphs are identical. Graphs are identical. So that means that we were able to complete our square by using our graphing calculator, but also by converting it to the form, or converting to standard form of our quadratic function. Okay, so function f is defined by x squared minus 9x minus 20. Determine the minimum value of f by writing the function in standard form. Okay, so we want to find out our minimum value of f, and so in order to do that, we are going to have to find out what the vertex is. Okay, and so remember, the vertex is going to be associated with our p and our q values. So let's figure out what this is going to be. F of x is equal to x squared minus 9x minus 20. Now let's follow our steps. Remember, the first step we needed to take is to take half of the numerical coefficient, which in this case is 9. So we have to take half of that and then square it. Okay, so half of negative 9 is negative 9 divided by 2. And then if we square this, this is the same as negative 9 over 2 times negative 9 over 2, which would give us 81 over 4. Okay, so then we're going to have f of x is equal to x squared minus 9x plus 81 over 4 minus 81 over 4 minus 20. Now remember, we want to write this as a perfect square. So this is the perfect square we're going to form. F of x is equal to x, and if we square that, that was 9 over 2, and that's squared. And if we have 81 over 4 minus 20, remember, if you're struggling with this part and you want to do it quickly, you can just put this in your calculator. Negative 81 divided by 4, and if I want to subtract 20 from that, we can then express this as a fraction, negative 161 over 4. It's negative 161 over 4, and that is our equation. So our vertex, remember, that has to do with our p and q values. And if you don't remember where p and q is, this is p and this is q. And so our vertex is going to be 9 over 2. It's not negative, it's positive, because this is going to switch our sign when we take it out. And our vertex was, or our y value, or q value, sorry, is negative 161 over 4. And so this also has to be our minimum value of f. This is our minimum value of f. Negative 161 over 4. Now, writing f of x is equal to ax squared plus bx plus c in standard form by completing the square. What we did last time was we weren't working with the coefficient of ax squared. Okay, so before we were just looking at this coefficient of b, but now we have a and b. So let's look at these steps. First step is to use the coefficient of x squared, so that's going to be our a value, as a common factor for the x squared term and the x term only. So we want to use these two as common factors. And then basically we're taking the same process that we did for the other ones, so for the first one. So take half the numerical coefficient of the x term and square it. So remember, this is our x term. So we're going to take half of b and then square it. And then we need to add and subtract the squared number in step 2 inside the brackets. Okay, so exactly what we did last time. Then we want to multiply the term which has been subtracted in step 3. So this term, we want to multiply that one by the coefficient of x squared, and then combine with the constant term. And then we want to form the perfect square, and within the brackets we want to write that in factored form. Okay, so let's take a look at what's going to happen here. Okay, so this was step 1, step 2, step 3, step 4, and step 5. So if we want to convert f of x is equal to 3x squared minus 18x plus 20 to standard form by completing the square, determine whether the graph of the function f has a maximum or minimum value, and then we want to state that value. Okay, so I'm starting out with f of x is equal to 3x squared minus 18x plus 20. My first step is to use the coefficient of x squared and find a common factor. And so if I'm looking at this, both of these terms here have a common factor of 3x. And so I'm going to take 3x out of here. But actually, instead of taking 3x, I'm just going to take 3 out. I'm going to leave my coefficients just so I can still have a perfect square formed. So I'm going to leave the x in there, but I'm going to take the 3 out. And that would be x squared minus 18, or minus, not 18, that's going to be 6x. So x squared minus 6x. This is why you don't do math in pen. Plus 20. So step 3 is take half of the numerical coefficient. Half of the numerical coefficient of x is 6. So half of that will be 3, and square it would be 9. So x squared minus 6x. And I need to add and subtract that squared number inside the brackets this time. So this is the only difference, is we're adding and subtracting it inside the square brackets. So then what we need to do is multiply the term which has been subtracted in term 3 by the coefficient. So all we do is multiply the term that's being subtracted. So negative 9 or minus 9 is being subtracted. We need to multiply that by 3 and then take it out of the brackets. So this is going to be 3, and I'm going to take, at the same time, I'm going to take this term and put it into a perfect square. That would be x minus 3 squared. And since I multiplied this one by 3, this is going to be negative 27 plus 20. Okay, and so then our final answer is going to be f of x is equal to 3, x minus 3 squared, negative 27 plus 20 is going to give me negative 7. So remember, this value is q. On our vertex, that would be a minimum value. Since it's opening upwards, this would be a minimum value of 7. Minimum value of negative 7. Okay, so blah blah blah. I'll let you do this one by yourself. Okay, so all you need to do for this one is, rather than writing it as y is equal to 7 plus 10x minus 2x, you're going to follow these exact same steps as you did up here and for this question here. And the only difference is you want to find out which way is the vertex, or what are the coordinates of the vertex of the parabola. So basically, is it opening up or is it opening down, and then what are those specific points? Okay, let's do this last question though. Express f of x equal to 3x squared minus 12x minus 8 in completed square form, and then use this form to determine the zeros of the function. Okay, so if we're looking for the zeros, we're basically going to have to well, factor it out and yeah, solve for the zeros. So let's start. F of x is equal to 3x squared minus 12x minus 8. And if we're beginning with what we just did in class example number 3, then what we need to do is we need to take out this coefficient and this coefficient by finding the common factor, which in this case is 3, which would leave with us x squared minus 4x minus 8. Now remember, what we need to do is take half this term and square it, and then put them both in the brackets. So that would be 3x squared, half of 4 is 2, 2 squared is 4, and we need to add that and subtract it. And remember, what we need to do next is subtract or multiply this term that we're subtracting by this coefficient that we factored out. So that'll be 3 times negative 4. And at the same time, we're also going to put this into a perfect square. So that's going to be 3 times x minus 2 squared minus 12 minus 8. Okay? The next thing we need to do is simplify this equation, which would be 3x minus 2 squared minus 20. Now we want to find the zeros of this equation. So remember, our zeros are the same as our x-intercepts, which means that our x-intercept would be when y is equal to 0. So zeros are going to be equal to 0, since if we replace f of x with our equation of y equals 3x minus 2 squared minus 20. Since y is equal to 0 when we find our x-intercept, then that's going to be 0 is equal to 3x minus 2 squared minus 20. And now we just solve for our x's. So I'm going to bring the 20 to this side. 20 is equal to 3x minus 2 squared. I'm going to divide that by 3 to get rid of this 3 here. So I'm dividing this by 3 on both sides. I'm going to be left with 20 divided by 3 is equal to x minus 2 squared. And I need to take the square root of both of these sides to get rid of that square. And remember, if I'm taking the square root of this, the answer would be plus or minus, since I don't know if I was using two negatives to give me this number. So that's going to be plus or minus rad 20 over 3, and that is equal to x minus 2. And so in order to solve for x, I'm going to be left with x is equal to 2 plus or minus, because I'm bringing it to the other side, 2 plus or minus 20 over 3. And we want this answer to the nearest hundredth, so we do actually want to solve this out. Okay, so if I were to put this into my calculator, where is there no reflection? Here we go. Okay, so let's see what 20 over 3 is first. 20 divided by 3, and I want it to be plus or minus that. So if I add 2 to 2.58, blah, 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 then I'm going to have an x value equal to 4.58 if I round to the nearest hundredth around here. And if I have negative rad 20 divided by 3 plus 2, I'm going to have negative 0.58. And those are my two zeros.